Okay, we're back for the third video for week 3. We're going to look now at unions, intersections, and complements of events. Okay. Determining outcomes for unions, intersections, and complements of events. So we're still working here with probability. A number cube with faces labeled 1 to 6 is rolled once. The number rolled will be recorded as the outcome. Consider the following events. Event A, the number rolled is greater than 4. Event B, the number rolled is odd. Give the outcomes for event A or B, event A and B, and the complement of the event A. Okay, let's write out our sample space here. So we know that when you roll a die, you can end up with 1, 2, 3, 4, 5, or 6 as your outcome. Okay, the outcome for event A is the number has to be rolled, has to be greater than 4. So greater than 4 doesn't include 4, it means more than 4. So we're going to call that event A. The probability of A is going to be 5 or 6. So those are numbers that are rolled that are greater than 4, these two here. Event B, probability of B, is going to be the number rolled is odd. Well, that's 1, 3, and 5. So first we're going to write out what our events are. Then we're going to give the outcomes. Okay, the first one is event A or B. Okay, I want you to write this out as A union B. And what does that mean? When you have or, we're looking at a union. Union thinks, I think about marry, like, holy matrimony. Who approves this union between two people, right? When you're at the altar. So you're going to marry them together. Whenever you see that or, okay? So when we marry things together, we're going to look at everything in probability or the event A and everything in event B. And so A or B means we're going to marry everything together. Okay, so what does that look like? Okay, so when these two sets get together, and we have to marry them together, okay, we're using the or. Well, we have 1. That's going to get married along with 3. Okay, and then we have a 5, which both of them have a 5. And this one has a 6, so we're going to take that 6. So think about this is like when you get married, sometimes you combine your property together. So in this particular person, when they bring to the marriage the 5 and the 6. So you want to make sure 5 and 6 is there. This person brings a 1, a 3, and a 5. So a 1, a 3, and a 5. So 5, you don't have to write it twice. We just have to show that it's there. So for example, maybe this event, they have a dog and a cat. So we bring the dog and the cat. So this is the dog, and this is the cat. And maybe this relationship, the 1 is let's just call that a hamster. This one's maybe a parrot. And this one is a dog. Okay, so in simplest terms, when these two get married, when we union them together with the or, we're going to take the hamster. That's number 1. We're going to take the parrot into the marriage. That's 3. We're going to take the dog. There's the dog. There's the dog. And then this one's going to say also they want to bring the cat. So we're going to bring the cat. That's the 6. When you see the word and, so A and B, I want you to think about what's in common between the two. What's in common? Sometimes I say, where's the overlap? Overlap or intersection between the two. Okay, so A and B, we're looking for what's in common. Well, this has a 1, they don't. This has a 5, that one does too, so we'll take the 5. This one has a 3, no 3 here. But the 5's already in common, and this has a 6, but there's no 6 there. So we're looking at what's in common. The only thing in common between what this person's got and what this person has is the 5. So it's just going to be the 5. Now the last one is the complement of the event A. So I also think about that as what is not in A. Okay, out of this whole sample space. Okay, so sometimes we call it A like that, or sometimes people will call it A prime or A naught. Okay, like what's not in A? Well, in A, we have 5 and 6. So that's these two right here in the whole universe. What's not in A is 1, 2, 3, and 4. And we're going to look at a Venn diagram, which will help with this a little more. Okay, let's move to the next sample. I think it's going to be very similar, so you can kind of practice. Yep, instead of using a die, we'll go with marbles. A marble is selected from a bag containing 8 marbles numbered 1 through 8. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8. As all of those, that's the potential outcomes. The number on the marble selected will be recorded as the outcome. Consider the following events. Event A, so this is a probability of event A. The marble selected has a number less than 4. Well, let's write out what that would be. So less than 4 would be 1, 2, or 3, the first, the second, or the third marble. Event B is the marble selected has an even number. Well, we know our even numbers. That's going to be 2, 4, 6, or 8. Those are supposed to be those fancy pants curly brackets there. Okay, so event A, number less than 4. Event B, number has an even number, or the marble has that they select has an even number. So I want you to think about A and B, A or B, and the complement of event A. So give that a try and then come back and see how you did. Okay, when we see the word and, I want you to think about what's in common. What's in common? Where do they overlap? Or intersect? And that's between event A and event B. Well, 1's only here, 2 is an overlap, 3 is not in here, 4, 6, and 8. So the only thing that's in common is 2. So it's just 2. What's in common? Well, where do they intersect? Event A or B, remember, is that union. It's the marriage between the two sets. So let's marry them together. So we have a 1 here. This one doesn't have a 1, but they're getting married. So we're going to take the 1 into the marriage. They both have a 2, so we'll grab a 2. Maybe they're toasters, right? So we'll take a toaster. This one here has a lamp, so we'll grab that 3. That's the lamp. This one here has a sofa. This one here has a TV. And this one here has like a KitchenAid. So we're marrying them together. We should end up with 1, 2, 3, 4, 6, 8. So 1, 2, 3, 4, 6, 8. Okay, what's not in A? What's not in A? Okay, so we know A has 1, 2, 3, but what's not in A? Well, that's the rest. The other marbles. Okay, so this is all very, it can be kind of confusing. So on the next slide, I tried to give you visual learners, like I'm a visual learner. I gave you something to kind of look at that might help with what we're doing here. Okay, so determining outcomes for unions, intersections, and complements of event. So here's a visual of what's in set A, it's just what's highlighted. What's in set B is what's highlighted. What's A prime or what's not in A? So A naught would be everything outside of A. What's not in B with everything outside of B. The union or the marriage between A and B. And then what's in common? Where's the overlap? So hopefully this visual is going to give us a little boost here. So keep in mind, this box is considered a universe. So there's all these numbers in the universe: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and even 0. So you'll notice some numbers are in set A, some numbers are in set B, some are in common, and some are just hanging out outside in the universe, but they're still in this set of numbers. So let's go through event A. Event A is going to be, if you think about this, here's A, everything in that circle here that's yellow. So we're going to write that out as, let's see here, we've got 1, 3, 5, 7, and 9. 1, 3, 5, 7, and 9. Now pause the video and go through and figure out what event B is and finish the rest of these questions. See how you do. Okay, if you're back, event B would be 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Okay, that's event B, just those here. Okay, event A and B. All right, so remember A and B, that actually is going to be this right here. So the and is really an upside down horseshoe, and the or is the union. So this is and this is or union. Okay, so we want the and. So the and, remember, is the what's in common. Where's the overlap? Where do they intersect? And that's this piece right here, 1, 3, and 5. Okay, 4 says give me A or B, right? A or B. That's A union B. That means you're going to marry everybody together. Now keep in mind, it's just the people in sets A and B, not the people lurking in the universe. So we have 1 toaster, 2 dogs, 3 parakeets, 4 hamsters, 5 TVs, 7 sets of sheets, and 9 teacups. Okay, so we're going to marry them together. So it's 1, 2, 3, 4, 5, 7, and 9. Okay, what is not in event A? So sometimes I use my hands to kind of think this through. So the complement of A is going to look like this. Okay, so it's like A prime, A naught, what's not in A. So if you covered up this, you probably can't, I can't do it with my hands on the screen, but like if you cover up what's in A, then you want to take everybody that's not in A. Okay, so you want to cover up what's in A, take everybody what's not in A. Same for B. Cover up everything in B and take everything that's not in B. So A naught, this is A naught, this is B naught. So if we cover up everything in A, we're left with 0, 2, 4, 6, 8, 10. And if we cover up B and we take everything that's not in B, we've got 0, 6, 7, 8, 9, 10. It's a lot going on there, but hopefully these visuals will help. All right, we're diving a little deeper. Okay, we're still going to be working through finding out what's in A, what's in B, what's the marriage, what's the intersection. We're going to add a little extra. So this Venn diagram below shows 13 students in Mr. Diaz's class. So we've got Mr. Diaz's class with all of these students. The diagram shows the memberships for the computer club and the softball club. Notice that Bill and Henry are still in the class, but they're not in computer or softball. One student from the class is randomly selected. Let A denote the event the students are in the computer club. So this is event A. And I'll let B denote the event the student is in the softball club. So that's going to be event B. Okay, so first we want to find out who is hanging out in event A, who's would be in the computer club. So pause the video and think about this time we're looking at probability, right? So we're looking at probability. So that's a little different. So before we would just name, in our previous example, we would just name the outcomes, but this time we're going to look at probability. So I'm going to highlight this or circle this because that changes things a little bit. So we have 13 total. The probability that you come in and select somebody out of Mr. Diaz's class and he or she happens to be in the computer club is going to be 1, 2, 3, 4, 5, 6, 7, 8 chances out of 13. So it's 8 out of 13, the probability. Well, the probability that someone comes into Mr. Diaz's class and randomly picks out people that are on the softball team would be 1, 2, 3, 4, 5, 6 out of 13 total people in the class. Okay, remember, or means we're going to union or marry them together. All right, so we want everybody, the probability that somebody were to come in and pick out a student that happens to be in computer or in softball. Okay, so we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 chances out of the total class of 13. Okay, that's the union. Now remember, and means, so this is or means union, and is like, looks like this. This is the intersection. Intersection, or sometimes I call it the overlap, or sometimes I think about it as, so the intersection, the overlap, or what's in common. Okay, so the probability that they would come in and randomly select one student from the class, and they happen to be in both computer club and softball club would be these 3 people there. So 3 out of 13. Okay, now they want you to take the probability of A plus the probability of B and subtract out the probability of A and B. Well, the probability of A is 8/13 plus the probability of B was 6/13 minus the probability of A and B is minus 3/13. Well, we're in luck. With fractions, you got to have common denominators, which we do. And then you're just going to add and subtract the tops just like we did with expected value. So 8 plus 6 is 14, minus 3 is going to give us 11. Okay. What probability is equal to probability of A plus probability of B minus the probability of A and B? Well, that's 11/13, which is the same thing right there, which is the probability of A or B. So they're kind of driving us to a little formula here. So we know the probability of A plus the probability of B. So all in A plus all in B minus what's in common, because you don't want to double count these people, the probability of A and B is always going to be equal to that union, the probability of A or B. All right, so hopefully that makes a little sense. Okay, so we just got a few more and then we will end this video here. A city planner surveyed 146 residents. For each, the planner recorded whether the resident owns a car, whether the resident lives alone. The results are summarized in the table. So this is a two-way frequency table here. So we notice that we have a car, owning a car. They live alone. They don't live alone, but they own a car. And these people, 28 people have no car and live alone, and 64 people have no car and they don't live alone. Suppose a resident from the survey is chosen at random. Okay, more probability. Oh, surprise. Answer each part. Do not round immediate computations and round your answer to the nearest hundredth. Okay, this one I left the solution on here so we can kind of think about it and explore it. The highlighting in the table shows us the number of residents who own a car because they ask us, just find the probability that the resident owns a car. Well, that's going to be these people right here. So let P, the probability that they own a car, to be the probability that the resident owns a car. So how did they calculate this? The number of residents who own a car, which would be these people here, over top of the total number of residents surveyed. So they must have added up all these people. Actually, they did for us here, 146. So 7 plus 47 is 54. That's these people that own a car. Divided by 146 is 0.369. And rounding to the nearest hundredth, we get 0.37. So if you're unfamiliar or you just forgot about rounding, 0.369. If you round to the nearest hundredth, 100 has 2 zeros on it. So we're gonna go out 2 decimal places, put up a door. This one here is gonna look here for guidance. That 9 tells the 6 to go to the 7. So that's how they're getting 0.37, or a 37% chance that the probability, or that it's a 37% probability that the resident owns a car. Okay, let us try to look at a different one. Okay, still the same residents, but now they're asking us, what's the probability that the resident owns a car but does not live alone, or does not live alone? Okay, finding the probability that the resident owns a car or does not live alone. The highlighting shows the number of residents who own a car. Right here, we know those people don't own a car. And they don't live alone. So these people here are not living alone. So this is not alone and the car. Note that we don't want to double count the 47 residents here who own a car and do not live alone. So you don't want to add them in twice. So a couple ways to go at this. You could, let's see here, a couple ways to go at this. The way I would go at it, let's see how they did it. Number of residents who own a car or do not live alone was these 7 people, the 47 and the 64. Okay, that's fine. Let's just do it that way. That seems easier, just to grab the alones, the not alones, but they own a car, and then we'll add in the people that are not alone. So 7 plus 47 plus 64 over top of 146 gives us 118 out of 146, which is 0.808, which rounds to 0.81. So this was sort of just like, I just snipped this from the homework to give us sort of a template to help us as we answer these last 2 problems. Yep, 2 problems. Okay, on a particular day, a restaurant that's open for lunch and dinner had 177 customers. Each customer came in for one meal. An employee recorded at which meal each customer came in and whether the customer ordered dessert. The data are summarized in the table below. Okay, suppose a customer from that day is chosen at random. Answer each part. Do not round your answers to the nearest hundred. Don't round to basically the bitter end. Okay, here's the question they're popping. What is the probability that the customer came in for dinner and ordered a dessert? Okay, on a particular day, a restaurant that's open for lunch and dinner had 177 customers. Each customer came in for one meal. So an employee recorded, the data are summarized. Okay, so these are people that came in for lunch. 37 came for lunch and had dessert. 73 had no dessert. For dinner, 58 people showed up and had dinner and dessert. And for dinner, 9 people showed up and had no dessert. What's wrong with these people? Why wouldn't they have a dessert? Suppose a customer is chosen. What is the probability that the customer came for dinner and ordered dessert? Okay, so the people that came for dinner, so this row here, and ordered dessert, this column here, would be these 58 people here. So 58 out of 177 equals 0.3276. They want us to round to the nearest hundredth, so come over here. The 2 looks at the 7, and we're going to get 0.33, or a 33% chance that the customer came in for dinner and ordered dessert. Okay, same chart, but this time they're asking what's the probability that the customer came in for dinner or ordered dessert? Okay, or ordered dessert. Well, in that case, we want to take a look and see that they came in for dinner, but they also ordered dessert. So it's going to be 37 plus 58 plus 9. So 37 plus 58 plus 9 over 177. So let's see what that is. 37 plus 58 plus 9 is 104 over 177. Let's going to be 0.5875. So 0.59. Okay, so a 59% chance that the customer came in for dinner or ordered dessert. All right, we'll see you next week. Good luck.